We are going to start out the lesson for the second half of 8.4 with a starter. I want you to think about how you would solve these problems. Now, I'm going to give you a second, think about it. If you need to, pause and maybe try it on your own. You could always grab a calculator, but then you're going to end up with some decimal answers. And if this were a quiz or something, the answers might not be wanted in decimals. So how would you do it? Well, with these here, sine negative 120, your next instinct would be to grab your unit circle. So your unit circle is going to be so helpful to you. And we focused a lot on it a couple sections ago, but we're still going to use it. So, just a quick review of the unit circle. So if you have one handy, look at it. And I'm going to look on my unit circle. I'm going to find 120 degrees. And that's in quadrant number 2. It's in the upper left corner. But I'm going to think, negative 122. I'd flip that across the y-axis. So that would be down in the third quadrant. And the coordinates would be negative 1/2, negative square root of 3 over 2. And since I'm looking for the sine is the y value. So the sine would be negative square roots of 3 over 2. Now, if you did put it in your calculator, you would have gotten the decimal negative 0.866, which if you put the square root of 3 divided by 2 in your calculator, it is 0.866. So you can use a calculator to check your answers. That's okay. Okay, tangent of 5 pi over 6. So you find the value for 5 pi over 6. And this time, the coordinates are a negative square root of 3 over 2 for the y value, and 1/2 for the x, or the x value, and 1/2 for the y value. Got that mixed up. Tangent is opposite over adjacent, or when we have the coordinates on the unit circle, it's the y value divided by the x. So we have 1/2 divided by negative square roots of 3 over 2. How do you divide by a fraction? You take the second one and invert it. So it's 2 over square roots of 3, negative, the 2's cancel out, rationalize the denominator, and your answer would be negative square roots of 3 over 3. Okay, tangent of 300 degrees is in the fourth quadrant. So you look down there and the coordinates are 1/2 negative square roots of 3 over 2, just the opposite of this one right here. So we would do negative square roots of 3 over 2 divided by 1/2. And this time, when you invert it and multiply, that's 2 over 1. The 2's cancel, and you just have negative square roots of 3 over 1, or just negative square roots of 3. Cosine of 11 pi over 6. Cosine is just the x value of the coordinate at 11 pi over 6, so it's square roots of 3 over 2. Okay, hopefully that was a good 3.5-minute review for you. So now we're going to look at the graph of the functions. And we're going to define them with some parameters. We're going to look at some things here. First thing we're going to look at is the amplitude. So amplitude is kind of similar to the word altitude, but in math it means a little bit different than that. Amplitude we're going to call the height. Then we're going to also talk about the periodic function, the cycle, the period, and the midline. So we're going to look at this graph right here. Let me move this screen. Okay, so here we have a graph. And this graph is cyclic in nature. It has a cycle because it repeats the same thing over and over again. So that's what we talk about when we talk about a cycle. And a cycle is the time or the distance, because sometimes time's across the bottom, that it takes for it to go through one complete cycle. So here we have it at the top of the graph, it goes down and up, it's back at the top. So that distance from the top back over to the top is what we call one cycle, and that is also called the period. The period, that is the length of one cycle. Okay, the midline is just like what it sounds like. It's the middle of the graph. Now this graph is not quite at the x-axis, so the midline would be halfway between this 2 and this -1, so it would be at about a half. So the midline would be this line right here at y equals 1/2. A periodic function, so I'm just kind of reviewing back to the words that we had up here. Periodic function is just a function that shows different cycles or periods. So let's look at this graph. So the period of this graph, so if we track it, and let's say we look at from where it's here at the y-axis, we can call that a height of 0. It goes up, down, and then back up to it. So this one has a period of 4 because it takes 4 units for it to complete the period. The amplitude is the height, and it's the height above y equals 0. So this one, even though the total height of the graph is different, we're only looking at the height from the midline. Oh, I think I said that wrong. It's supposed to be from the midline up. So it's basically half of the height of the whole graph. So the amplitude would be from 0 up to 1. So this one has an amplitude of 1. The midline is at 0. So when we're talking midline, it would be at this line y equals 0, but we can just put 0 because the midlines will always be horizontal. All right, so let's look at this graph. So this graph, and by the way, this graph is shown in radians. Notice that across the x-axis, it has it in radians, and we'll look at that a little bit later as we start graphing cosine and our trig functions. But for right now, all you need to know is how to find the period, amplitude, and midline from here. And notice that the period, so let's look at, and you can find the period starting anywhere. We usually start at 0, 0, just to, have a good starting point. So it goes down and up, and there you go. So this has a period of 2 pi, because from 0 to 2 pi, that's a distance of 2 pi. The amplitude is it looks like it's a little bit bigger than 1. So the amplitude would be from the midline up. So I think it's at 1 here. The midline is at 0. This graph is a little bit different because it doesn't look exactly like the ones we did before, but it's still a periodic function because it does repeat. So it goes up, has a little dip, up again, back down again. So this one has a period going from here to here. So how far or how long is that period? Well, it's 6 units. And then the amplitude, well, let's find the midline first. So it goes from -1 to +3. Halfway between that is 1. You could always find that by finding the average of the two numbers. 3 plus -1 divided by 2 is +1. So that's one way to find the midline, is to find the average of the two numbers, or you could count, you can see that the total height of the graph is 4, so 2 would be the amplitude, because from the midline up is 2 units, and the midline is at 1. Some other things that we will be looking at or interested in is how many cycles are there between a certain value. So if we were asked how many cycles between 0 and 2 pi, well, it's kind of fuzzy, but you can see on this graph here that 0 is right here and 2 pi is here. So it goes up and down and up, And how many times does it go through one cycle or one period? And the answer is 4. It has 4 cycles. Each period is pi over 2, and the amplitude is 1 because from the midline, which is the y-axis or the x-axis, up is 1 unit. So that would be the amplitude. How many cycles between 0 to 2 pi? If we look at this one, we can see that it goes through a complete cycle or a complete period every pi units. So if we're going from 0 to 2 pi is right here. So we can see that it had 2 cycles or 2 periods between 0 and 2 pi. Each cycle was 1 pi long, so each period was pi. The amplitude, the midline would be right here at 0. So the amplitude is 1 and the midline is 0. So some abbreviations. P stands for period, A stands for amplitude, and M stands for midline. So we can abbreviate those if we want to. Sometimes the graphs are spread out more. So how many cycles between 0 and 2 pi? Well, if you notice right here, it starts at 0, goes up, down, and back up again. So one complete cycle is from 0 to 4 pi. So to go from 0 to 2 pi, it was only a half of a cycle. So if you were asked how many cycles between 0 and 2 pi, well, it was only half of a cycle or a period, so it would be half. Some other things to look at on that, the number of cycles would then be 1/2. A period would be from 0 to 4 pi, so one period would be 4 pi. And looking back, the amplitude from the midline up was again 1. Okay, look at this graph and see if you can answer these questions. Pause if you need to. How many cycles from 0 to 2 pi? So if we go from 0, I'm just going to kind of mark that. We're going from 0 to 2 pi, and we're going to count how many cycles. I'm going to change colors here so I can mark it. Well, there's one cycle going from there to there, so 1. And here's another one. And there's another one. So we can see, sorry, I didn't trace that very good. We can see that cycles from 0 to 2 pi, there were 3 of them. A period was how far one cycle was. So we have we go from 0 to this point right here. And how are we going to find that point? So think about that for a second. How would I find out how long each cycle was? Well, here's a little hint. We know that in 2 pi, there's 3 cycles. So if we want to find what one cycle is, we would take 2 pi and divide it by 3. So there's just a really cool way to find how long the periods are, rather than to try to find that point right there. Now, if you were to check, that point would be 2/3 pi. And if you notice, it's 2/3 of the way to this pi right here. The amplitude is 1 again. Okay, so that was a good discussion about like sine or periods and amplitudes and stuff. So in the next video, we'll talk about graphing, sine and cosine.